this is Mr. Fish. Sorry I can't be with you guys today, but we'll have this lesson and then there is an assignment at the end, so you should be able to get started on this. Remember that you had an assignment due yesterday, or rather you had an assignment from the lesson yesterday that is due Monday, so then you'll have an assignment with this lesson today, so there'll be two things due on Monday. So don't forget about those over the weekend. This lesson is on areas of trapezoids, rhombi, and kites. And we'll have two objectives. One, to find areas of trapezoids, and the second objective, to find areas of rhombi and kites. Fairly simple lesson today, not too much heavy math, so hopefully you'll be able to get most of this done in class today. And maybe we'll even have time to get everything done so you don't have homework over the weekend. Jump right into it. Area of a trapezoid, and the explanation is here, but what we really want to see is the formula. The formula for area of a trapezoid is area equals 1/2 the height times the sum of the two bases. And a trapezoid is defined as a four-sided figure with one set of parallel sides. So two of the sides will be parallel, and those are the two bases. So find the length of base 1 and base 2, add those together, multiply by the height, and the height is the distance between those two bases. So it will always form a right angle with the bases. And so the sum of the two bases times the height divided by 2 will be our formula. So we can find the area of this trapezoid. Area is 1/2 times the height, which is 15, times the sum of the two bases, which would be 12 plus 26. So we'll just work through that. Area 1/2 times 15 is 7.5. 12 plus 26 is 38. And 7.5 times 38, the area is 285 inches squared. Of course, you'll have some problems where you have to get creative in finding some of the links that you'll need. Here's one example of something you might need to do. This figure is a trapezoid because there's one set of parallel sides, and we need to find a missing side length here so that we can use the formula. And what we'll have to do is make a line right here that sets apart this distance, and of course on this side that distance would be congruent, it would be the same distance. And now we have a right triangle here. We know that this height is 4 because it's got to be the same measurement as this. And so since that is 4 inches, now we can use Pythagorean theorem to find this part of the long base. So this is the hypotenuse, 8.5 inches. So we'd have 8.5 squared equals 4 squared plus that unknown distance here is x squared. 8.5 squared is 72.25. That equals 16 plus x squared. So we'll subtract 16 from both sides. And 56.25 equals x squared. Take the square root of both sides, and 7.5 is x. That means this part of the long side is 7.5 inches. Of course, now we can find this missing side as well, or this part of the side. It's going to be 2.5 inches. 2.5 plus 7.5 would give us the 10. And so we can fill in this part. Now we have both bases. So the area is going to be 1/2 times the height, which is 4, times the sum of the two bases. So 10 plus 2.5. One half times 4 is 2. 10 plus 2.5 is 12.5. And 2 times 12.5 is 25 inches squared. All right, next slide. The area of a rhombus or kite uses the same formula. Of course, a rhombus has 4 sides that are of equal length, like a square, except that the angles aren't 90 degrees like they would be in a square, aren't necessarily 90 degrees like they would be in a square. A kite has 2 sides that are the same length here, and then 2 sides that are the same length here, but many of the properties of a rhombus and kite are similar. And so they use the same formula for finding the area. And that formula is simply 1/2 times the product of the two diagonals. So diagonal 1 times diagonal 2, and then multiply by 1/2 or divide by 2, whichever you prefer. So 2 examples here. This kite, we'll use the formula area equals 1/2 diagonal 1 times diagonal 2. So area is 1/2 of 672. So area equals 336 centimeters squared. And then for this rhombus, area is 1/2. And here we don't have the length of the entire diagonal. We just have from here to here is 7 millimeters. So the whole diagonal would be 14. And then from here to here is 6, so the entire diagonal would be 12. So 1/2 times 14 times 12. And the answer that we'll get here is 84 millimeters squared when you multiply that all out. A couple more sample problems just to give you an idea of what you'll be doing in your homework. The first one diagonal of a rhombus is twice as long as the other diagonal. If the area of the rhombus is 169 square millimeters, what are the lengths of the diagonals? So just remember the formula. Area equals 1/2 diagonal 1 times diagonal 2. And the problem tells us that one diagonal is an unknown length, and the other diagonal is twice that length. And so we can substitute some things into the formula now. The area is 169 millimeters squared. 169 equals 1/2. Diagonal 1 will be x times diagonal 2, which is 2x. So 169 equals 1/2. X times 2x is just going to be 2x squared. And 1/2 times 2x squared is just going to be x squared. So take the square root of both sides, and 13 equals x. So now we know the length of diagonal 1 and diagonal 2 is just twice that, so d1 equals 13 millimeters, and d2 equals 26 millimeters. All right, the final sample problem. We want to find this distance here. This is a trapezoid. So remember the formula for the area of a trapezoid. Area equals 1/2 the height times base 1 plus base 2. And so we'll just fill in the measurements that we know. 177 equals 1/2 of 13 times base 1 is 11 plus x, which we don't know. I want to multiply by 2 to get rid of the fraction. So that's going to be 354 equals 13 times 11 plus x. Now just solve for x. 354 equals 13 times 11 is 143 plus 13x. Subtract 143 from both sides. 211 is 13x. Divide by 13 and it's about 16.2 centimeters for x. And that's all we need to do for the final answer. All right, the last page here is just kind of a summary of what the formulas have been in the last 2 lessons. And I know it doesn't print very well. It's kind of a small picture there on the paper that you have. If you can't read it, you can look it up. It's on page 792 in your books, and you can see it a little more clearly there. Maybe make notes if you need to. And that just, like I said, summarizes the formulas of the last 2 lessons. All right, here's your assignment. You should have plenty of time to work on that today, as well as finish up the assignment from yesterday. Remember, they're both due Monday. So I'll see you then. Have a great weekend.